Hello everyone, my name is Odarike Charles, and from the last session, I had shown you how to draw board plots for every filter, be it for active filter, be it for the passive filter. For today, I'm going to show you how now to implement the circuit for the low pass filter by linear. And we have seen that to simulate this, we are using a control library and to import the MATLAB, and we can do the board plot. So today I'm having a project whereby having a low pass filter with a cutoff frequency of 1 kilohertz, and I've really explained here and the value of the cutoff frequency and everything. So plotting it brings this kind of a plot. So this is my magnitude plot and this is the first plot. So I'm going to use LTspice to show you now how to simulate it. So to simulate it, I'm going to use LTspice, as you all know LTspice, and I'm going to use a simple what you call RC circuit. So I'm going to have a resistor, place it there. I'm going to have a capacitor, sorry, there, then a resistor, then I'll do what? I'll have a voltage source, just like that. Then I have all the connection. The shortcut for getting a resistor is R, the shortcut for capacitor is C, then the shortcut for voltage is V. Then I can have what you call ground, or just the common ground. So I'll connect this here and I'll connect it here. Then I'm going to have a value of resistor because from the design, you have seen that to get a cutoff frequency of approximately 1, we should have a value of a resistor as 15.9 kilohertz. So I'm going to have a resistor of uh, 15.9k. You can have it k, it just work. Then here I'm going to have a value of 10n. So from this, I'm going to have a value of voltage. But now, because I want to do the DC, like I want to do the analysis, I'm not going to use a fixed voltage. I'm going to use a voltage that has a change in frequency. So to do that, you're going just to right click. Then instead of having a fixed voltage, I'm going to have an advanced. Then from this, I'm going to have an amplitude of, let's say, 10, just 10, just like that. Then okay. So from that, after having that AC of 10, I'm going to have configure analysis. You can press shortcut is A, or you can use. So from that, I'm going to have, I'm going to come to DC AC analysis, and I'm going to use a decade, and the number of per decade I'm going to use 1,000. Let me use 1,000. Then I'm going to have a start frequency of 1 and end frequency because it's 1 kilohertz. Let me extend it to about 5 kilohertz. So I'm going to have 5,000, 5 kilohertz. So from that, I'm going to have this directive. So from that, I'm going only to simulate it. So simulate, you press this run. So I'm going to run that, and I want it to be tiled vertically. So like that. So then did the plot. Then what I'll have to do just to, because the output for the low pass is across the resistor. So just come and have it here. So you see, you're having a cutoff frequency at around this. Let me zoom to fit. This is the magnitude plot. This at the end, the other one is the phase plot. Okay, so you see the first plot run from 0 to 90. Then the magnitude plot is like decreasing. So to get the we can estimate where the cutoff frequency is, because the cutoff frequency is where is 0.7071 of the maximum value. So we can see the value is about, if you have a cursor, maybe let me have a cursor. Um, Place a cursor, then I can move it until you can see the value here. So the maximum value, we see the maximum value. You can see that the maximum value is about 9, around 20 dB. And as you move, as you move the cursor, you can see the value, the magnitude attenuates as increasing frequency. So let's say 20 times 0.7071, we are getting a value of 14, right? So we can move until we get a value of 14. Yeah. So you can see it's something like 1 kilohertz and something. So around, so you see the frequencies are around 1 for the cutoff frequency. So this is the way you can be able to simulate it. And thank you for watching. Kindly subscribe to my YouTube channel.